In this video here, we're going to take a look at Eulerian graphs. Now we can determine whether a graph is Eulerian, Semi-Eulerian, or neither by considering the degrees of the vertices. So as always with decision maths here, time for some definitions. So an Eulerian graph or network is one which contains a trail that includes every edge and starts and finishes at the same vertex. Now this trail is called an Eulerian circuit, and any connected graph whose vertices are all even is Eulerian. And a semi-Eulerian graph or network is one which contains a trail that includes every edge but starts and finishes at different vertices. Now any connected graph with exactly two odd vertices is semi-Eulerian. So Eulerian and semi-Eulerian graphs can be drawn without removing your pen from the paper. That's kind of why we've got this little icon here, right? And without repeating any arcs. And I'll demonstrate that on the next page here. That kind of concept though, where you can kind of draw it without removing your pen from the paper. In my case here, it would be my tablet, but you get the idea. So as we just mentioned then, let's just visualize some examples here of Eulerian, semi-Eulerian graphs, and examples of neither of those. So as we just mentioned then, let's just take a look at each situation here separately. So to get us started here then, we have an Eulerian graph. So this graph here is an example of an Eulerian graph. And just notice here then, all the vertices for this graph here have even degree. So this vertex here has degree 2, this vertex here has degree 4, and the same is true for these three vertices here. And then finally, this vertex here also has degree 2. So in that case then, all the vertices have even degree. And in that case then, that makes this graph here an Eulerian graph. Now for the next situation here, this is when we have a semi-Eulerian graph. So this graph here is an example of a semi-Eulerian graph. And just notice here then that exactly two vertices have odd degrees. So this vertex here has degree 3. The same is true for this vertex here. So these two vertices here are odd. This vertex here has degree 4. Same is true for this vertex here. And this vertex here has degree 2. So in that case, then we have exactly two vertices with odd degree. And in that case, then that makes this graph here a semi-Eulerian graph. And then finally, for the very last situation here, this is when we have a graph that is neither Eulerian nor semi-Eulerian. So I've got two different scenarios here. Now, these two graphs are neither Eulerian nor semi-Eulerian. Now, in the case of this graph here, more than two vertices have odd degree. So this graph would be neither Eulerian nor semi-Eulerian. It's actually impossible to draw this graph here, that's this graph, without removing your pen from the paper or repeating an edge. Okay, so this graph here is neither Eulerian nor semi-Eulerian. And then for the final example here again, this is neither Eulerian nor semi-Eulerian. And the reason for this is because this graph is not connected. So in that case, then it's neither Eulerian nor semi-Eulerian. And again, it would be impossible to draw this graph here without removing, I can't speak anymore, without removing your pen from the paper or repeating an edge. Okay, so there we have it then in terms of an introduction here to Eulerian graphs. So let's just work through a practice question together. So let's just get started here then with the one practice question for this video. Now for the first part of this question in part A, all we want to do here is determine under what conditions Kn is Eulerian. Now don't forget then, Kn here is a complete graph with n vertices. So K3 then is a complete graph with 3 vertices. K5 is a complete graph with 5 vertices. So on and so on, right? You get the idea. Now, we need to think then under what conditions will make Kn Eulerian. Now, if you're not too sure then, what I would just recommend doing here is drawing K3, K4, and if necessary, K5. Although I do think drawing K5 is somewhat unnecessary, but if you really do need that extra step, then that's fine, of course. But for now, let's just draw K3 and K4. So for part A then, let's just do this to the side here. So for part A then, now my art skills, if you've watched any of our previous videos, then you'll know my art skills are pretty shocking. But K3 is just simply a triangle, right? So this here is K3. So I've got 3 vertices, 1, 2, 3. I'll do those in a different color just to kind of highlight that. 1, 2, 3. And just notice here then, the order of each vertex here is 2, right? This vertex has order 2. This vertex here again has order 2. And this vertex here again has order 2. Now let's just draw a K4 here, and hopefully this will help illustrate the point that I want to make then for part A. So for K4 then, let me just do the vertices to begin with here actually. So K4 is simply a square. I'll try and draw it as a square anyway. And we have an intersection of diagonals here. So if I join this up, we'll get something like this, like so. And it cuts through the middle. That's pretty shocking. Let me try and redo that. It's not good. Try again. So I'll try it again. Let's give it a go. It'll do. It's okay. Anyway, that's K4. So this here is K4. Now just notice then, each vertex here for K4 has order 3. This vertex here has order 3. This vertex here again has order 3, so on and so on. So hopefully what you recognize here then is that Kn is Eulerian when n is odd. So K3 will be Eulerian, K5 will also be Eulerian, can't speak anymore, so on and so on. The same would apply to K7, K9, so on and so on. So let's just make a point here then. So Kn is Eulerian. So Kn is Eulerian when n is odd. Okay, now why is that the case then? Well, when n is odd, each vertex will have degree n minus 1, and therefore in that case then, it'll be even, right? So just make a supporting point underneath here. When n is odd, each vertex has degree or order, whichever you prefer to describe it as. I'll just put order here, has order n minus 1. And therefore even. And in other words, Kn is Eulerian. Okay, and there we have it then. So that's all we need there for part A. You don't have to draw the diagrams, but like I said, I do think it helps to kind of visualize and illustrate the problem to basically understand then what conditions are required there for Kn to be Eulerian. Okay, so there we have it. That gives the solution to part A. Now for part B then, all we want to do here is list the order of each vertex for the graph below. So I've got this graph here. You might recognize this from a previous video and almost a identical question almost. So let's just do part B then. So I've got our graph here, and all we want to do then is just list the order of each vertex for this graph, right? This table here is going to help us. So A, B, C, D, E, and F are the vertices for this graph, right? So what is the order then for each vertex? So vertex A has order 3. So order 3. Vertex B then has order 3 as well. So order 3. For vertex C, again, this has order 3. For vertex D, again, this has order 3. So what about vertex E then? Well, vertex E has order 2, right? There's 2 edges incident to the vertex E. So order 2. And then finally for the very last vertex here, F, this has order 4, right? 1, 2, 3, 4. Like so. Okay. So there we have it. Nice and straightforward. Then that gives us the solution to part B. And then finally, for the very last part of this question here, I'll just do this underneath them. So for part C then, it says, hence or otherwise determine whether the graph is Eulerian, semi-Eulerian, or neither. Now we need to recall then what conditions are required here for Eulerian, semi-Eulerian, or neither. Now, if the graph is Eulerian, then all vertices will be of even degree, which clearly this is not the case here. Okay. Now, if we have exactly 2 vertices with odd degree, then the graph will be semi-Eulerian, which clearly, again, this will not be the case here because I've got 1, 2, 3, 4 vertices that are odd. Okay. So what that means then is this graph here is neither Eulerian nor semi-Eulerian. Okay? So the graph has more than 2 odd vertices. I'll just take those vertices here. So A, B, C, and D. So those vertices there are my odd vertices, right? And in that case, then, because we've got more than 2 odd vertices here, then this graph is neither Eulerian nor semi-Eulerian. Okay? So therefore, the graph is neither Eulerian nor semi-Eulerian. Okay? And there we have it then. Bosh, good stuff. So there we have it then. That gives the solution to part C and the solution to the one practice question for this video here. And that brings us to the end then of this video here on Eulerian graphs.